Hi guys, welcome to module number 4. And module number 4 covers descriptive statistics, and under this module we will look at summary statistics, frequent tables, cross-tabulations, and measures of central tendency and dispersion. So moving on to our first objective, summary statistics. Under summary statistics we have some key STATA commands like summarize, like tabstat. And starting with the summarize will provide basic statistics like mean, standard deviation, minimum value, maximum value, and number of observations. As example, we can issue a command like summarize income and age. So it will give us both the number of observations, average value, minimum value, maximum value, and similar for each of the variable here. Now we have tabstat. It will give a customizable summary statistics such as mean, median, standard deviation, and similar. So if we say customizable, it means that you can dictate what to be produced at the end of the execution. Maybe you might be interested only to see the mean and standard deviation, or maybe mean and median, and maybe also only mean or average. And this is how you can issue the command to STATA. You just need to issue tabstat, for example, income, age, assuming those are the columns for interest, and we add an extra argument called stats into bracket. Now this is the statistics we want to come along these summary statistics of these two columns. We need the mean, we need the median, and we need standard deviation for income and age column. And looking at frequent tables, so we can produce frequent tables in STATA using tabulate tab command, tab 1 as well as tab 2. So let us focus on tabulate or tab. This one will produce a frequent table for categorical variable. And example, you can say tabulate gender. The moment you say tabulate gender, then it will give us the frequency table for the gender column. For example, it will be male and female. So it will give us how each category is distributed. And now tab 1, remember it's for categorical, this tab or tabulate. But now let us see tab 1, what it does. Tab 1, it will generate one-way frequent tables for multiple variable. One-way frequent table for multiple variables. So you can have more than one variable to provide their frequent table. So we have tab 1 gender education, so it means we need frequent table for gender and education. On the other hand, tab 2 is also used to produce frequent tables, but now it is different from tab 1 and tabulate in such a way that it will generate two-way frequent tables for pairs of variables. Remember, it is for pairs of variables. And example, you can say tab 2 gender and education, which means it will be a two-way frequent table. It's like a single table with all these statistics distributed. And we have now cross-tabulation. Instead, we can produce cross-tabulation table using the tab command, and we provide like a variable number 1 and variable number 2, and you can add on extra argument, row, col, and cell. Remember, in STATA, the moment we issue command like comma, it means that anything after comma is treated as an option. So it means that you can as well run this line successfully without this section. It will still run successfully. And the moment you add on row, col, and cell, this one will display a contingency table with options for percentages, such as row percentage, col percentage, and cell percentage. So we are going to see this in practical part. And this is the example in STATA. We just need to write tab and followed by the two variables for interest. For example, gender and education. We'll have a distribution of percentages across rows and column. In fact, we'll have both frequent and percentage across both row, column, and cell percentages. And let us have look at measures of central tendency as we wrap up the descriptive statistics theoretical part. So stay along because we will be transitioning quickly to practical part. So measures of central tendency, we have purpose and you have STATA command. So mean is simply the average value and it will summarize the income. It will summarize the income. If say for example summarize income, it means it will give us the 5-number summary for the income. Median is simply the middle value, and to get that you need just say centile income. For example, if you're interested in income, then centile 50, which means we need the 50th percentile. A standard deviation is simply as the spread of data, and instead to get standard deviation, you just issue the command tabstat. Our column of interest, in fact, it should be numeric or continuous variable, comma starts, we need standard deviation. And on the other hand, also to get variance, it's almost similar to summarize, but now we have to add something called detail. And remember, variance is just a spread of data, and in fact it's a spread of data squared. And now we have range, mean, and maximum. They also represent the data spread. And to get that, you need to just command summarize income, for example, and say comma the detail. So you need to add on further details. So let us see this in practical part. I'm in STATA, and I've also opened our do file. And remember, this do file is module number 4 that deals with the descriptive statistics. And as tradition, I'm also specifying the file path where my data is located. So throughout this, almost 80% of our analytics will entail this data, this sample data that we'll be using. So we will be familiar from module to module with this data. So first thing first, we need first to import the data or to load the data, and we have to execute this line. And running this line, we find that our data is now active. From this side, from the variables window, we have the data, and from the result window, we have the command here, and during the command window, we also have the command here. Now, what follows after we load the data? After we load the data, we are going to the next now objective, which will need summary statistics for numeric variables. And before we do that, we need to again to remind ourselves of the differences between tabstat, tab1, and tab in STATA. So starting with tabstat, we need to understand that tabstat will provide summary statistics like average, median, standard deviation, minimum value, maximum value, and those should be for numerical continuous variables. And on the other hand, it can also display multiple statistics in just one command. As well, it is useful for detailed numerical summaries. Now let us try to understand tab1. How is tab1 different from tabstat? So tab1 produces one-way frequent tables for a single categorical variable. Remember, it is for single categorical variable, while tabstat is for numeric variables, and we can maybe more than 2. And tab1 is specifically for single categorical variable. And remember, categorical data or variable is just a data that or a column that is in grouped format, like level of education, level of you can say level, you can say maybe your health status, other thing maybe you can say the region you come from, something like that. And tab1 as well, it will show the counts and percentages of each categories, and it's useful for symbol frequency distribution. And let us now also see how tab 2 or just tab is different from tab 1 and tabstat. Remember, you can issue command as tab 2 or just tab. And tab 2 from the word, I am adding this because it's an optional, but you can just issue with tab. It produces, unlike tab 1, tab 2, it produces two-way or one-way frequent tables. So it can do both one-way and two-way frequent tables, and can cross-tabulate two categorical variables. Can cross-tabulate two categorical variables, and it shows both counts, and optionally it can also show row, column, and total percentages. And now it is useful for examining relationship between two categorical variables. And now, in a nutshell, we realize that we use tabstat for detailed summary statistics for numeric variables. On the other hand, we use tab 1 for distribution of one categorical variable. And similarly, we use tab or tab 2 for cross-tabulation, and that is two variables or one-way tables for more options. I hope that is at your fingertips before we proceed. Now, right away to our objective, let us issue the command summarize age, income, and survey. Before we do that, we need to browse our data so you can understand how our data is organized. So our data, we are just reminding ourselves how this data looks like, and this is the same data we were working on from the other modules. This is the data that contains ID, age, income, gender, income, level of education, religion, employment, health status, the year, and the survey weight. And it has 50 observations. And you can see now we want 5-number summary for each of these columns. Let me execute and can minimize to check the output. So we have three variables here: age, income, and weight, or survey weight. We have both of them have 50 observations, meaning we don't have any missing instances. Average, the average age is 36 years, and average income is 44.3, okay, 44,320, and the average survey weight is 1.156. And we have the minimum age, or the youngest person is 25, and the oldest person was 53 years old. And the least income is 29,000, while the maximum income is 60,000. On the other hand, survey weight is 0.8, that's minimum, and maximum is 1.5. So, having seen some gist about 5-number summary for those three columns, we can now start with the tabstat command. So, line number 41, we are running the tabstat for age, income, for age and income, but we need tabstats related to, in fact, tabstat is simply a cross-tabulation or just a frequent table that is interested for these two columns. And remember, tabstat is used for to produce frequent tables for data with numeric variables. So like age and income have numeric data. So, and we need stats related to mean, median, standard deviation, minimum value, and maximum value. And I will not explain these columns. What does these columns mean? But let us issue, and I will explain the command. And I just did the same thing on line number 42, but now I have omitted these columns. So let me first of all just run the command, and you will see and explain. So now you realize that after you're running that, we have this table. And what we notice that age and income are represented as observation, while their statistics are represented as columns. Now that's why you are seeing these columns, which means you want statistics to be displayed as columns. So what you note that by default, the statistics information here, this statistics data, will be represented as observations or represent as rows, but you can customize to interchange them by appearing as columns. So for example, age, you have average age is this, average income is this, 50 percentile you have this for age 50. So I hope you understand what does 50 percentile mean. It means that at most 50% of your respondents are aged 6 years and below. And in this also means that at most 50% of the respondents earn 45,000 USDs per annum and below. That's what it means in simple terms. So I hope you understand that. So let me again use now the same command I told you about now without having to include column statistics. So we plot it in default format. So with default format, you realize now the columns or the variables will appear now as columns, and then the statistics will appear as rows. This makes sense to you? And now it's time to proceed. So in short, what this tabstat does is simply it summarizes variable by showing a specific statistics. And this one of the specific statistics include mean, median, standard deviation, mean, minimum value, that is, and maximum value. And provided you don't want, for example, minimum value to be shown, you can do away with it and you execute this. So checking the outcome in the result window, now you realize that we don't have the minimum value, but here we have. So that's how you can do some maximization, or sorry, some modification to frequent tables. And for example, age income simply means that the variables to summarize will be age and income, and stats, mean, median, and standard deviation and mean and maximum simply means that it will be the statistics to calculate and display. And column statistics simply will arrange the output of so the statistics are shown in columns instead of the default row for easier readability. And now let us tabulate or produce some frequent tables. So we want to plot frequent table using STATA. And in STATA, to create a frequent table, you just need to issue command tabulate. And upon running this, we find the frequent, for example, the frequent table for region. We have that in region we have 4 regions: east, north, south, and west. And realize that east and north have equal distribution, as well as north and south have equal distribution. And this 12 represents as 24% of the total respondent, while 13 represent 26%. Again, you can create a frequent table for more than one column and realize that it is a cross-tabulation of region versus education. So you realize that for guys from the East region, no one has a bachelor's degree, but 3 of them have diplomas, 2 of them have high education level as high school, and 5 of them have masters, 2 of them have PhD. And the total guys from the East region are 12. And for maybe also looking at South, we have 4 guys with a bachelor's degree, 1 guy with a diploma, 3 guys with a high school level of education, 0 person or no person with masters, and 5 guys with PhD. So that's how you can interpret that. And moving ahead, let us see what is next. So we can now use tab 1. We have already used tabstat. Now we are moving to tab 1 to provide some statistics based on categorical variable. And remember that tab 1 can produce, we said by definition that tab 1 is used to present statistics for a single categorical data. But there's a way you can customize, so you can issue a command. It can do up to 2, in fact, categorical variable. But if you add more variables, it will have to complain. Let me try to do this. This is for tab 1. We use gender, education, and employment. And tab 2, we are using gender, education, employment, and health status. Let me run and compare together. So we need to compare this. Let's compare now. So this is the command we issued. Let me scroll. So we have this tab 1 command. This tab 1 command of gender, education, and employment gave us 3 tables, frequent tables. You have tabulation of gender, you have male and female, and this is the distribution. We have education, and we have this is the distribution: bachelor's, diploma, high school, master's, and PhD. And we have employment: unemployed, self-employed, employed, self-employed, and unemployed. And on using tab 2, you realize that now it is like a single table. But for tab 1, in tab 2 it is a single combined table. But in tab 2 we have it's just a single table. If it's employment, it's employment. But with the tab 2, it will give us a one combined table that compares gender, for example, and level of education, and says the tabulation of gender by education. And it will also give us another table of gender versus employment, and gender versus health status, as well as education versus employment, and education versus health status, as well as employment versus health status. So which means we have several tables here. We have like table number 1 for gender and education, table number 2 for gender and employment, table number 3 for gender and health status, table number 4 for education and health state and employment, table number 4 education and health status, table number 5 employment and health status. So we're picking 5 tables. So table 1 is here, table 2, table 3, table 4, and finally table 5. I hope now you understand the difference between tab 2 and tab 1. Now we want to do a cross-tabulation, guys, and it will be cross-tabulation based on gender and health status. And we need also row, column, and cell percentages. So using this command, let us check what will happen. So this is what happens after using this command of tab gender. In fact, this you can use tab 1, tab 2, or just tab gender, health status, and you issue extra options like row, col, and cell. So row stands for row percentage, col stands for column percentage, and cell will stand for cell percentage. So for example, in female gender, you have under gender we have female and male, and we have totals. Under health status we have excellent, fair, good, poor, and now totals. So for this one, it means that under excellent, with the excellent health status, we have 7 females. With fair, we have 9 females. With good health condition we have 4, and with poor we have 5, and all this adds to 25. This is the raw totals. And on the other hand, male we have 6 with excellent health status. We have 4 male with the fair health status. We have 10 with good health status, and we have 5 with poor, and this total we have also 25. And now we have this 7. So to get this, let me first of all go to get these totals. We have to add the column totals. 7 plus 6 we get 13, and 9 plus 4 we get 13. 4 plus 10 we get 14, and 5 with 5 we get 10, and finally 25 plus 25 we get 50. So meaning that the total sample size was 50. And now to get this 28%, it's like we need to take 7 out of rows total, which is 25 times 100, we will get this 28%. And now to get the column percentage of female, which will be this 7 over 13 times 100, which is this, which is 53%. And now to get this cell percentage, it will be 7 over totals, which is 50, times 100, we get 14%. And this runs across even for male counterparts. I will repeat for male using this I'll repeat for male with good health. So you have 10 for male as with good health conditions. So the percentage, this 40%, comes from taking 10 over 25 times 100. We get 40%. And 71 comes as a result of this 10 over 14 times 100. We get 71%. And this 20% comes from 10 over 50 times 100. We get 20%. I hope you can do for the rest and you can understand now. Thank you. So I have here some explanation, and how I wish that I will upload this material also you can understand. So I've explained this material here, but I hope you have also explained from the results, so you can proceed from where we need to proceed from. So we also need to get some cross-tabulation of region and employment. I also need to add self percentages and row call and self percentages. So running this is what we get. Like for East region, we have this kind of guys who are employed, this with self-employment, and for unemployed totals we have 12. So we have total percentage of people from East who are employed are 16.67. This comes from the 2 over 12 times 100 to get 16. And the cell percentage, sorry, column percentage is calculated by taking 2 over total, which is 20 times 100. 2 over 20 times 100, we get 10%. And this cell percentage of 4%, we get 2 over the total is 24. 2 over 24 times 100, we get this 4%. And now the same can also be applied to this, and now we can proceed with. We can also now move now direct to measures of central tendency, and in this case we need to get the mean and the income. Just say mean income. So income is the column of interest, and upon executing this there, the result we're getting. So it's loading. So this is the result we're getting, that the average for income after issuing this command, we realize that we're getting the average to be 44,320, standard deviation at 1348.148, and this is the confidence interval. So this confidence interval, the one giving us this mean value, because you will get this plus this over divided by 2 or over 2, you get this result. And now we can also get the 50th percentile, and in STATA we use centile instead of percentile. So just you need each command centile. For example, we need to get the middle person or the middle age. So that's why you're issuing the median and age of age. So it will be centile age, comma 50. Okay, comma centile 50. And remember, anything I said after comma is optional. So you can still get the centile of age without issuing this extra statement. This extra statement here. We want to be specific. That's why we are saying we just need 50 percentile, not any other. And let me check the result. So we get that 50 percentile of the age is 36. This is the middle age or the median age. And finally, let us create or compute the standard deviation by just saying sum standard deviation of income, sum, income, and comma detail. We'll get the standard deviation by running that. So I've executed, and now this is what we get. It gives us the percentile from the first percentile to 99 percentile, and it also gives us the standard deviation similar. So this is the standard deviation. We have also variance. We have skewness, kurtosis, etc. So guys, this marks the end of module number 4, and I hope you've understood something. Please kindly support us by subscribing to our content. We will appreciate that. Thank you.